Hello, this is Miss Becky again, and today I'm going to be going over IXL in Precalculus section H1, and we'll be looking at exponential functions, specifically the domain and range of these types of graphs, as well as their equations. Now, exponential functions, if you remember, they have the variable in the exponent, and when they are graphed, they cause a shape that looks like this, a um, kind of a quick growing curve or a quick um, de um, decay, where if you remember when we read these graphs from left to right, if it's heading up like this, that's positive, which is going to be growth. And if they, again, reading the graph from left to right, starting up here, this graph is going down, signifying a decay. The parent function will look like this. It will be y, which we also call f of x, is equal to b, which is the base, raised by some exponent. What specifically we'll be looking for the domain and the range of these values. But first, let me show you something. So in real life, they would use these types of graphs to present like population growth. This one we can see the population is growing. This graph over here, these are showing the difference between how exponential growth of interest, which is the compound interest, it just grows so much faster than just a simple interest like this one, which is just a linear equation. So this could actually be a good thing for you if you're gaining that money, or it could be a bad thing for you if that compound interest is on a debt. Examples of bacterial growth. Here you can see it's growing on this graph. Here it's stationary, and here is the decay or the death of the bacteria. And we can measure the rate of decay in all kinds of different things. Here's one last example of decay, and hopefully we don't have any type of that decay going on. That's pretty gross. More specifically, we're going to be looking at the domain values and the range values of the graphs, as well as the equation. So this is the very basic parent um, equation right here. It's just the base with the exponent. You can multiply this parent graph function by other values. You can also add and subtract to to the equation, and also to the exponent, which will then raise the graph, lower the graph, make it grow more quickly or decay more quickly. Now, the good news for the domain values in an exponential function is that the domain, which are the x values, always going to continue out towards negative infinity this way, and the x values will always go towards positive infinity. So that's always going to be the domain of these functions. So that's pretty easy right there. The range, which are the y values, and if you get them mixed up, you can think like the g to the range kind of dips down, as well as the y sort of dips down like that also, if you forget. Now the y values are going to be wherever this graph is and above. These exponential functions, they have what we call an asymptote. So they grow very, 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 very close to this line here, but they will never cross it. So the range values are never going to touch that asymptote right there. Real quick things before we jump into some of the examples are the very beginning parent function of, excuse me, these exponential graphs. They will always go through this point here where x is 0, y is 1. That's where they begin, starting right there. Now, another thing that we need to understand is this interval notation that you're going to see. You're going to see the parenthesis here, which means that the number is greater than the range, or the domain is going to be greater than whatever value you put in there. Such as in this example, the range right here is showing us that the domain is that it starts at, gets really close to -1, but that value is not included. And then it goes all the way to the value of 3. This bracket here means that that 3 is actually included in that. Another way you will see that, it might look like this, that the range is going to be between -1 and +3. That's how that's laid out like that. So again, this is less than, and it's not equal to that -1. And here it's great, n, or the range, is greater than or equal to, or less than or equal to 3. It also can look like, here's another example, where obviously you can't include a negative infinity value, so you're going to use a bracket there, and this means that this range goes all the way over to a 3, which is included. Again, that can look like this in an inequality notation. Other things that you're going to see are, again, remember, negative infinity is this symbol, positive infinity is this symbol. And so on your graph like this, x on this end is negative infinity. Over here, it's positive infinity. The y-axis, negative, is down here. Positive is up here. Now, again, for the domain, for these graphs, they're always going to be all real numbers. And that's what this notation looks like here. That represents all real numbers. But it can also look like this in interval notation. So you're going to see these different things as you work through the problems. Also, you will see set notation looking like this. Oop, looking like that. And it's pretty much just read that all y is such that y is greater than 5. So this is just another way that you're going to see that. But let's just look at some of the problems here. On this problem, number 1, always look for what they're asking you for. They just want to know what the domain is. But the good news is the domain will always be all real numbers. So that one's pretty easy because they've written it out. All real numbers. And that one. Now on this one, again, they just want to know the domain. Again, it's just going to be all real numbers. That's pretty easy. But had they been asking you for the range, that's going to be a little bit different because this number right here, whatever is added or subtracted to that to this equation, is going to represent this asymptote. So this graph is growing, and it's going upwards towards -5, but it will never touch -5. So the range is going to be from negative infinity all the way up to -5. And you would write that like this. It goes from negative infinity to -5, but you have to put the parenthesis because it's never going to include that number. These graphs never ever reach that number fully. On this one, if we're looking for the range, This one, there's not a number written here, but we can assume that there is a 0 added to it. Um, so I'm guessing, well, they're not wanting to know the range. They're wanting to know the domain on that one. So that one's going to be all real numbers also. In this example, number 3, they're asking you for the range, and they're giving us a graph. So we're looking for the y values. So this graph is going down towards negative infinity, and it's going to continue up towards positive infinity. So that's going to be all real numbers right here. On this one, they're also asking for the range. Um, and we can see that there is an asymptote right here at 8. So written in this notation here, that's going to be where all the y numbers will be less than, but not equal to 8. In this next example, they're asking you for the range. Now, don't be fooled because you see this right there. We're looking for the number that's not added to the exponent, but that is added off to the side here. And we can assume that it's a 0. So that means that there's going to be an asymptote at 0. So it would be something like this. So it's going to approach 0, but it's never going to touch it. And that would be where all of the y values are less than, not equal to 0 because it will never touch it. On this one, it's a bit easier because they're asking you for the domain. And domain is always going to be all real numbers. Examples here are this graph. We can see that the graph is below this, what is that, -7. So it's never going to touch -7. So that is going to be for the range, is what they're wanting. It's going to be negative infinity up to -7. Now on this one, they're asking for the range also. We can look at the equation and assume that there's a positive 0 added. It's this number here that lets us know that asymptote. So the graph would only exist from negative infinity up until 0. This last one, for the range, it's going to be this number here in that position. And so the graph is only going to exist for all the values for y that are less than -1. Again, I apologize for my voice and not sounding so great, but hopefully this can make some sense to you, and I'll do better next time. Thank you.